We've mentioned a lot of challenges that needs to be addressed to get to net zero. So next, we have 5 amazing startups sharing their solutions that can be used to address those challenges. And first, I would like to invite Taisang to talk more about their solution.
Hello, everyone. Nice to meet you all. Thank you, first of all, organizers. Allow us to showcase our technology. So we are Taisang. We're developing quasi-solid-state sodium battery. And today I'm going to show what we have done so far. So in general, we started from standard sodium-ion cells, which still have a low energy density in gravimetric as well as volumetric. But to increase this metric, we need to have solid-state electrolytes. So ceramics and sulfides, they need expensive and complex equipment, but also there is a high resistance interface to achieve scalability. So you need a stacking pressure, but at the same time you need high temperature to enhance ionic conductivity. But if you look on polymer, still ionic conductivity at room temperature is a challenge. And looking at the sodium metal anode, there is a risk of expansion. At the same time, there is a dendrite growth as one of the most challenges to enable solid-state sodium battery. So what we have done is we are looking for 2 battery formats. One is cylindrical. Currently we build pouch cells, but the second one, it is a structural battery where we place electrodes inside the between carbon fiber, and we call it structural battery. I'm sure you came across it. You can bend it and then put it on the vehicle body structure, so anywhere you want. So that's a material where we place energy storage. In general, what we have done is we have 2 main IP that enables us to achieve high room temperature ionic conductivity, but reach a low cost, which is important. We roughly estimate 50 pounds per kilowatt hour at the mass scale. In general, first one, it is we combine 2 monomers with 2 different properties, which enables us to have high mechanical structure, but again, conductivity is important. We use in situ polymerization, which allows us to have high scalability using existing lithium-ion facilities. At the same time, what we have is a great interface, which enables us to reduce dendrites or SEI growth. At the same time, sodium metal, we also combine it with another specific metal where we generate artificial layer, which again reduces the dendrite growth once we cycle. So there are many good companies and startups around the world, but we really wanted to make sure we increase high performance energy density, but keeping the low cost. So looking at this, we wanted also to use materials that are actually proven at scale as well. So in that field, we are mostly stand out in volumetric. We're reaching roughly 600 watt-hour per liter, but at the same time, in the terms of cost side, we are in the lead-acid battery segment, which was also important for us to use to be kind of attractive economically once we scale. So I wanted also to be transparent where we are right now. We are currently conducting multi-layer pouch cells, but so far what we achieved is a coin and 1 layer for now. And then we actually achieving high capacity, and in general what we want to use is we are using physics-informed neural network to accelerate our development timeline, and roughly we estimate 35% time reduction. So what we have done in terms of commercial side, we have 19 non-binding MOUs with various automakers starting from low volume and high volume. They are also varied in terms of product segment, and we also done kind of a contract with eVTOL company where we done a great software development on that. In general, we have 6 engineers. 5 of us are PhD, and then it's a good mix of academia and industry together. So we also thank to UK ecosystem, where they allowed us to achieve good non-dilutive grants. At the same time, we also fundraising in our pre-seed round. And yeah, we are open to discussions with any battery, automotive OEMs, and try out some pilot projects. Yeah, thank you so much for your time, and happy to meet after the sessions. Thank you so much.
Thank you, Sanzar. Next, we have Justin to talk about Phyllis.
Hi, my name is Justin. I'm the co-founder and CEO of Phyllis, and we make the sun shine at night. I'm going to tell you a bit about hardware. I'm going to tell you a bit about why you need software to make that hardware successful, and I'm going to have an ask at the end of the pitch, so please listen. Now, renewable energy is the cheapest source of electricity. We had a lot of conversations about that today. We understand that when the wind isn't blowing and the sun isn't shining, we have a problem if we don't have storage. That's what we're doing. We're doing long duration energy storage, so that starts at 8 hours, going all the way up to 30, depending on who you ask, even longer. There's many different technologies. You can use electrochemistry. We said, no, let's use air. Let's use air, steel, and gravel to store large amounts of electricity. These are not materials that we're going to run out of anytime soon. We're breathing air every day, after all. How does this work? We have developed our own unique new process for liquid air energy storage. So the same way you can boil water and make water vapor out of it, and water vapor can condense back into liquid water, you can do the other way around into low temperature and do that with air. What we bring new to the table is that we make it as a scalable and a sustainable and ultimately a profitable solution in a containerized and modular fashion. So that means, especially also when it comes to critical materials, that is not an issue. Now, that sounds all nice, especially on the capacity side, it's very low cost. The issue is, when we talk with customers, with corporates, they want to know, where's the profit? How do I understand the risk? How do I understand the profitability? And if you want to build up traction as a startup, you need to get these customers to actually commit to something. So what we did, by the way, this is a picture from our lab, almost forgot about that. So yeah, we target 3 different customer groups. We have the renewable energy developers, we have the grid system operators, and the commercial and industrial players. They have different incentives. The commercial industrials, as mentioned earlier, they want to reduce cost. And you have the developers, they want to increase revenue. But they all need flexibility. They need to somehow provide electricity or buy it when it's cheap or sell it when it's cost, when the value is high. Now, what we developed is a software that allows you to understand and simulate in detail across more than 10,000. Sometimes we have customer projects with 30, 40,000 simulations at an hour interval to understand really how would an energy storage behave. And this is important because that allows us to build up traction. This has allowed us to get large customers like Ørsted, like Wien Energie, Austria's largest utility, to work with us, to work with the teams directly on actual projects and generate revenue for us. It has also allowed us to go forward towards actually building our traction for our hardware solution. Because if you want commitments for a hardware solution, you always need to show what does the project look like? Where are the financials? Where is the risk? What is the uncertainty? And if you can provide these answers and benchmark, you will also understand who you have to compete with. So that's what we have been doing. Now, when it comes to the business model, we've heard about finance today. How do you finance these projects? We will start with selling these systems. We are not like rich with capital that we can just fly it around. I don't know, my English is losing me right now. But eventually we have identified partners that we can even build towards leasing. Now, why is leasing interesting? Many people, many customers think in specific project time horizons, 5 years, 10 years. And our systems last 20 to 30 years. Now for us, that makes an incentive misalignment. Now when you do leasing, at the end of the lease, we have the right to buy back that product. That means we can then deploy it in energy storage as a service. We get access to low cost like infrastructure and start benefiting from a longer lasting product. We align the financial incentive with the sustainability incentive. Who's doing all that? That's our team. So we are five management team. The team has grown by now to around 12 people in the company. coming with different backgrounds: material science, physics, chemical engineering, energy engineering, business psychology. And this is the team. We actually need to a newer picture there soon. Now, I told you a lot about the hardware, I told you about the software, and I told you that I will ask you something. And if there's one thing I want you all to remember from today, it's that we are building this because we want 100% renewable energy to become a no-brainer. I always say you should be a fool to run a coal plant.
We have Andrew to share more about Oxy CCU.
Hello, everyone. Well, thank you very much for having me. Real honor to be here today and to tell you a bit about Oxy CCU. So, to start with, the obvious fact, but actually not widely understood, but it's that we need hydrocarbons in a net zero world. That's not because we like the fossil fuel companies, it's because the carbon-carbon bonds and the carbon-hydrogen bonds have these specific properties that means that they have very high energy density and also the versatility to make chemicals and plastics out of them. This is a considerable demand that will outlast net zero, so we must think of how we can get hydrocarbons in a net zero world. We cannot get them from fossil fuels anymore. We know this. The world's getting too hot and we need to stop. The first attempt was, of course, the first generation biofuels. In the US, most importantly, ethanol, and in Europe, it was biodiesel. The challenge is land use. We now know that that cannot scale to the point at which we can satisfy all of hydrocarbon demand. So then you realize quite quickly that whether or not it's second generation biofuels or whether it's e-fuels, that we're into the business of converting CO2 or CO, or a combination of CO2 or CO plus hydrogen, into hydrocarbons. Yes, of course, eventually we need to move to full circularity with biogenic CO2 and direct air capture, but in the short term we can get started with industrial CO2, reduce oil demand, and of course we need a lot of electricity to make hydrogen. But this is absolutely possible. And where we sit as a company is in that dotted circle there, and that's the catalysis to convert CO2 and hydrogen into hydrocarbons. This is the key to reducing cost. And we know in the past that we've seen breakthroughs in catalysis lead to things people originally thought were very, very difficult, and now we do on an enormous scale. Nitrogen was a very, very stable molecule similar to CO2. Nitrogen plus hydrogen to form ammonia is also thermodynamically favored, but you need the right catalyst to convert it. CO2 plus hydrogen is also thermodynamically favored, but you need the right catalyst to form the hydrocarbons. So we're a spin-out from Oxford University focused on novel catalyst and reactor designs for CO2 utilization. This was our Series A funding round, led by Clean Energy Ventures and Kiko, part of IP Group, and backed by a number of corporates who you'll see there. The real breakthrough we have was published in Nature in 2020, and it showed that with a single pass, CO2 plus hydrogen over an iron Fischer-Tropsch catalyst, you could get C8, C9, C10, so that's 8 carbons in a row, 9 carbons in a row, 10 carbons in a row, all the way up to C16. That is jet fuel range. So we're talking about feeding CO2, hydrogen, and getting liquid hydrocarbon fuel out the other end. And this simplifies the process that most other companies are focused on today, whereby you go CO2 to CO, and then CO plus hydrogen with Fischer-Tropsch to oil. So we've simplified that by having both what's called reverse water gas shift and Fischer-Tropsch happening on the same catalyst surface. So we've got a breakthrough in catalysis that leads to a simpler process, reduced capex, reduced opex, lower cost of fuel. Business model is similar to the other catalyst companies that are out there today. So we manufacture catalyst and we license the reactor design to the project developers. The project developers are the oil companies or the independent project developers. We license catalysts and sell catalysts and license reactor designs to them, similar to those businesses that you'll see below. Thank you. And if you want any more detail, got any questions at all, very happy to speak afterwards. Thank you.
Thank you, Andrew. So next we have Philip to share more about Ennodyne.
All right. It's always nice to speak right after somebody that does pretty much the same thing, but with a different technology even. So I'm Philip. I'm the CEO of Ennodyne. And what we are doing is we're focusing on getting profitability and fighting climate change in the same bucket, basically. And we're doing that by producing chemicals and fuels from CO2, and we're aiming to do it with the same or even lower cost than today's petrochemical alternatives. And that means for climate change, we sequester loads of CO2, we defossilize the chemical industry, meaning that we stop CO2 even entering the system in the first place, and all of that we do by closing the gap towards the circular carbon economy that we already saw before, and that is, as we heard in the beginning of the day, really elegant, really. So the technology we are doing that with is called non-thermal plasma catalysis. So we're not only using a catalyst, but we're using plasma to energize the CO2 because it's super inert. And with that, we can get carbon dioxide and a hydrogen carrier into green chemicals and e-fuels in the single energy efficient process step. More detailed, that means that we can use CO2, we can use carbon monoxide, we can use hydrogen, and we can also use green methane from biogas plants, for example, and produce all those shorter chain C1 to C4 hydrocarbons that you see on the side. So we can produce methanol, ethylene, formaldehyde, basically all the building blocks of carbon-based chemistry. At the core of the technology, we've got this. A patented high-tech ceramics material that we use as an active electrode, and that is actually what makes our process so energy efficient. Because we can ignite a non-thermal plasma with less than 50% of usual technology as with usual electrodes. And that means that we can not only get to fossil prices, but we can also get to or even below fossil energy consumption, which is really vital to get sustainable chemicals in the first place. The process is also extremely flexible because we can have very short startup and wind down time, meaning that we can also use the technologies in areas where we just have very, unstable energy supply, unstable carbon supply, and so on. The process is also extremely scalable because instead of just heating everything up, we use plasma, and that means we can pursue a modular design, allowing us to mass produce the technology at a central location rather than just building a plant next to the plant every time, and then just decentrally deploy it to a variety of use cases like biogas plants, like cement plants, steel mill, and so on. So far, we have validated the technology in the lab. So we have validated the efficiency potential, we validated the electrode material, and we showed that we can produce all the different hydrocarbons that I just mentioned. And the next step is going to be to build the first clustered version, put it next to a biogas plant, and get it on the road. And from there, it's just a small step towards a fully scaled container version that you see there on the right-hand side, and to commercialization roughly around late 26, early 27 maybe. To accomplish that, we built up a world-class team covering basically all the different sub-disciplines of plasma catalysis, so engineering, catalysis development, and also plasma engineers. And we surrounded them with an interdisciplinary partner network involving academic partners helping us with foundational research, and also with industrial partners helping us to just adjust already existing technologies to our technological core. So far, we've raised 4 million euros, amongst others, from the German Federal Agency for Disruptive Innovation. And in the next step, we want to raise 10 million euros because now we can start parallelizing development and can just go pursue pilot plants and get ready for business. So if you also want to become part of a sustainable future that combines profitability and the fight against climate change, here's my details, and I'm happy to talk to you afterwards. Thank you.
Thank you, Philip. Now, last but not least, let's learn more about Novosil.
My name is Bjørn Olav Brelin. I'm the CEO of Novosil, and I'll take you over to the metals recycling industry. We have in Novosil developed a new process for solid state recycling. This audience, know quite well how metals recycling is done today, basically through different melting processes. You know the benefits clearly, bringing used material back into life, often at qualities that are equal to that of primary metal. You may also know some of the challenges, one being the relatively high energy consumption that goes into a standard melting process. Another challenge, which you may not know too much about, is that these conventional processes, they are often not very well adapted to small particle materials. And the reason why this has been important for us is that we started out in Nuvosil from the solar industry and tried to find a way to recycle small particles that are made from cutting of silicon solar wafers. What you can see on the little video here is similar materials from the aluminum industry. And the challenge with that is that this is very energy intensive to recycle, and normally yields from the recycling process is very, very low. So it means that normally it is taken out of the primary value chain and recycled in as secondary material, with the obvious negative effect both on value and in terms of sustainability. So what we've done is that we have created a solar a solid state process where we do not melt the material, but we compact it through a screw extrusion process. Even if the material is not melted, we end up with a density level on the end material which is equal to melted material. This technology was initially developed for aluminum, but we've expanded to different aluminum alloying materials such as the silicon that I mentioned. The main benefit of this technology is the very low energy consumption compared to the alternative conventional process. We have compared data from our test facility with information from our recycling partners, and as you can see from the slide, the reduction is quite significant. Comparing process to process, energy consumption is 70% less with our technology, and reduction in CO2 is up to 98% lower. Part of the reason why the CO2 reduction is higher is that when you go from conventional technology to our LER process, you also go from natural gas to electricity as an energy source. So where are we? We have the first ever built industrial scale pilot up and running at our test facility in Norway. We are now, that's what you see on the video, we are now at version 3, or we are designing version 3 of this tool that will be a 24/7, 365 commercial machine. Parallel to the tool development, we are working closely together with our recycling partners to develop end product, test and qualify that. And where we go from here is that we expect to be closing the design phase on the commercial machine by mid next year. After that, we will install extruders at selected recycling partners, and based on the experience that we gain from that, we will start commercial rollout planned beginning of 2025. Thank you so much for your attention.
This is going to be the end of our day one. And tomorrow, we are going to have quite an agenda. Many of you probably know we have a code of conduct for our core values in TDK Ventures. C for contribution to society, O is one team reaching for the sky, D is for delivering deep inside, and E is entrepreneurs first. Hopefully, Today you saw that we are embedding all of them, and it's going to be the same tomorrow. So please join us back tomorrow and share all the insights and leverage these insights to make better decisions for our planet. Thank you.